Hello, everyone, and welcome in. Thank you for joining us for today's webinar. Before we get started, I just have a couple of things to go over. So the first is that we are recording the session and we will be sharing the recording with everybody who registered. We also have a question function turned on, which you can find in the top right corner of your screen. If you guys have any questions, from the presentation today, you can add them there and we will have some time at the end to go over them. So I know we've still got some people joining, but we're going to go ahead and get started. So welcome everybody, and thank you for joining us for today's webinar on agent-driven detection engineering. Today I am joined by Rajesh Sharma and Joe Mastromarino. Thank you both for joining me today. I'll hand it over to you, Rajesh.
Thank you, Liz. Can you hear me?
Yep.
Excellent. Is my screen also visible?
Yes, it is.
Excellent. Thank you. Welcome, everyone. Thanks for joining us. Today, actually, I'm very excited to share with you some of the lessons we learned reducing frictions in detection workflows. So what I will do first, I will go through a bunch of slides to set the stage or to provide some context. And then my colleague Joe will go over a live demo. Okay. So let's a brief word about us. My name is Rajesh Sharma. I'm the co-founder and chief architect at AttackIQ. Last 3 years, I've been super focused on leveraging recent platform shifts for optimizing the AttackIQ engine for many different use cases, which Gartner put them under CTEM, like continuous threat exposure management. So before AttackIQ, my most notable contribution came in as a principal engineer writing kernel device drivers in the network and storage stack for Windows, Mac, and Linux, mainly for digital forensics companies. You might have used a lot of these products. You might have used NKS Forensics or Access Data Forensic Toolkit, FTK, they are known by. So with me, I have my colleague Joe. Joe, please go ahead, introduce yourself.
Sure, thanks for that, Raj. Yeah, Joe Mastromarino, Director of Sales Engineering here at AttackIQ. I've been here for just shy of 4 years. This topic here today. When they brought it to me, I got super excited because it's a topic that's near and dear to my heart. Because prior to my time at AttackIQ, I spent about 6 years living inside of this world in detection engineering. Logging, writing rules, just helping customers build out SOCs with a SIM at the center, and making sure that all of those rules that they have makes them actually secure and not only feel secure. So I'm super excited to talk about the advancements that we've made into making these workflows especially work a whole lot better. So thanks for that, Raj.
Thank you, Joe. So Joe, you probably remember when we first created our breach and attack simulation platform. In the beginning, we initially thought the main usage will come from the red teams or the pen testing team, the testing and evaluation teams. However, we started seeing a strong adoption coming from the blue teams, especially among the detection engineers. But then working up close with these people, these enterprise detection engineers all over the world, we started seeing the same pattern again and again. Maybe you guys have seen that too. There was a lot of friction in their daily workflows. Guess what most of these teams were using to track and validate their detection rules? Excel spreadsheets. A lot of the teams are still doing that today. However, we realized one thing, that the problem these guys were running into were not anything new. These problems have been around for quite some time, even before we started the company. However, solving those problems but was not easy until now. So today, I would like to share with you one such approach that's making a difference. But before that, let's touch briefly on the problem. I think you know this problem very well. A SOC is buried in alerts, and these alerts are coming from the rules that you have put in place. A huge majority of these rules, you inherited them from the vendors, and a lot of them you organically created them over many years. And now we see this thing in survey after survey. More than 50% of the analysts say they are buried in alerts, and more than 80% say that they're burnout. This burnout has led to actual breaches. Now you may be wondering, why is this problem so hard? Why can't we fix it once for all? One word: entropy, physics, second law of thermodynamics. Things always tend to break. Let's take your people, for example. They change jobs, they move on, their roles change, your security controls get updated, their configuration changes, the logging formats change. What about threats? Threats always evolve. But what about your detection rules though? They don't change. They age, right? And they don't age like wine, more like cheese. So how do we fight this drift? So how do we inject some energy into the system to bring some order to this chaos? This is where I would like you to consider one such framework that we are exploring. It seems to be working for our customers. I call it agent-driven detection engineering, ADDI for short. I don't know if I will share with you marketing at AttackIQ. Don't let me name anything. But anyway, think of this as a continuous cycle which has four key parts, and these key parts are working together with each other. The first one is interpret, that answers question like, what does this rule even do? Then validate, does this work against real world attacker behaviors? Then measure how well it works against the drift. And then finally generate, how do we create better rules faster? But for any of these things to work, you need solid foundation, right? Our rules need proper home. It can't be Excel spreadsheet. Why? Because our rule need proper structure, proper data model, and proper relationship. That's why we built this service called Detection Rule Manager service, which Joe will later cover in the demo. What does this service host? It will house these obvious things like your rules of different types. Those Sigma rules, those Yara, Snort, their source of origin, which vendor you got these rules from, which GitHub repository or community you got them from, or which internal team. Also, which claims these rules are making, what MITRE tactics and technique they claim to cover, and also other dependencies like related product and logging sources. So you may wonder why go all through this hassle. It's because it's easy for the agents to talk APIs than talk spreadsheets. Okay, our rules have proper home. Now, what's the first question or the main question on the analyst's mind? Understanding existing rules. Maybe you have seen this report from Ponimo, where they say an average SOC within a week sees about 22,000 alerts, and close to half of them are false positive. You can imagine the frustration among these analysts chasing these ghost alerts coming from the rules that they don't even understand. Maybe it has happened to you. You had an alert that's backed up by a rule which looks something like on the screen. You read event ID 4104 and you scratch your head. What the hell is this rule supposed to catch? I didn't even write this rule. It was written by a guy probably long gone, or maybe it came from a vendor that you have no channels to talk to. And what happened to rules like this? They just sit there, right? And they rot, causing even more false positive. But this is exactly where a rule explainer agent will explain in plain English. It will explain, sir, the rule you're looking at is for the PowerShell scripts, which is downloading code into memory. It's very common in fileless malware. Is related to MITRE technique T1059, command and scripting, and subtechnique 001, PowerShell. Plain English, clear context, clear intent. So bottom line, we're saving our analysts precious minutes. And you know these minutes matters because when you have 22,000 alerts a week, every minute counts. Okay, our analyst understands the rule. Our rule looks good. But you know, a rule that looks good but doesn't really detect anything, it's not very useful. It's just pretty YAML, right? What's the next thing on the analyst's mind? They will say, how do I test this damn thing? And you know that's not easy because you have seen many testing platforms, both open source and commercial. What is one thing common across all of them? They all have thousands and thousands of tests and of many, many different modalities. Even for the AttackIQ platform, I can share with you, we have atomic scenarios, we have attack graphs, we have PCAP, email, WAF, on and on, which is extremely valuable if you're a red teamer or a pen tester, or if your job is testing and evaluation. However, if you want to validate detection rules, that can be a real problem, right? This is exactly where our validation agents kick in. A content matcher agent will help you find the right piece of content, the right modality for your rule's intention. And a content builder agent will help you craft, create, or tune the right type of content for your rule. One lesson we learned by working with these large enterprises all over the world, no matter what any vendor says, it's near impossible to predict your environment, to 100% have a test in our repository which is ready to go to test these rules. That's why these content builder agents are actually more important than we think. Then assessment planner agent that will use the above found or created content to create a test plan, to create a test of the highest efficacy to test your rules. So bottom line, all these agents are trying to help our analysts from the manual effort of finding, creating, and configuring these tests, which can take very, very long time. Especially if in SOC, if you have like thousands and thousands of rules, which we have actually seen. Doing all those work for thousands and thousands of rules can be really cumbersome. Okay, our analyst has understood the rule. He has also validated them, and the rule fires. Awesome, that's progress. But is it even effective? So detection engineering is not about like this firing alerts or firing rule, these detections all day long, right? What's the next thing on our analyst mind? Maybe you saw this report from Mandiant. The mean dwell time of the attacker globally is 11 days. So attacker is in our network for 11 days before they are detected. The question of the analyst's mind will be that how do I shrink this window? But this is exactly where measurement agents kick in. How does they help? They will help you see that for all the rules that you have put in place holistically, how are these rules performing? Are they even working? Then specific agents like integration agent will make sure that the decision of disposition of an alert, like whether it was a false positive or a true positive, doesn't just get lost in the ether, right? It doesn't get lost in your Splunk or ServiceNow. This information shows back to detection rule manager so that this information can further be used by the precision and the recall calculator to see which of these rules are getting noisier over time or their precision is decaying. There's one thing you probably have seen. Detection engineering is not very similar to technical debt. People are very afraid of deleting existing code or existing rules. They're very comfortable adding new rules. But you need a systematic way of seeing that, hey, do I need to tune this rule or maybe delete them for better or worse? And the last agent, as the name clearly suggests, will help you map your rule to MITRE ATT&CK matrix so you can systematically track where your rules have a proper MITRE coverage, where they may have maybe gaps. And this all become very important when you have thousands and thousands of rules. Doing all this work of tracking this progress across all these rules can be pretty time consuming. But you can also see the nature of the conversation changes, right? It changes from did my rules fire to which of the rules are helping me cut the attacker dwell time. Okay, our analyst has understand the rule. He even validated them and also measured them. What's the next thing on their mind? Threats, right? Threats never sleep. They may be thinking, what about threat landscape? How do I convert this mountain of CTI into detection rules? But this is exactly where our generation agents come in to support our analysts. The CTI decomposer agent will take your 57-page CTI report and extract the artifacts. We will extract things like IOCs, IOAs, IOBs, LOL bins, TTPs, command lines, CVEs. Once you have extracted all these artifacts, and this is the important part, a human analyst, not any AI, or at least that's something that we have not found yet, human analyst who understand your environment, your industry, your vertical, to create a test evidence at the right level of the pyramid of pain. And then they may use this test evidence at the lower level of pyramid pain or the higher level of pyramid pain to use rule builder agents to create rules that may be a signature type rules, for example, Yara rules or SNOT rules, or maybe behavior type rules, right? Like, for example, a Sigma rules or KQL rules or Splunk SPL, right? So we just covered all the 4 pillars of our ADDIE framework, which are powered by 4 sets of focused agents. We saw the agent that helping us interpret the forgotten rules, agent that helping us validate them against reality, an agent that help us measure what truly matters, an agent that help us generate better rules faster. You probably saw one thing in our discussion. We are not talking about a lights out SOC automation here. We're talking about very narrow, very focused automation unblock our analyst. And also you probably saw, we're only talking about using of this technology for the problem spaces that's already showing a very good signs for. So it's not a fake full promise. Now I will give the control back to Joe for the demo. Joe, please take it away.
Sounds good. Thanks for that, Raj. Now we've seen the talk about this. Now let's have this thing in action, right? So let me go ahead and share my screen out. Give me 1 second. Let's go share, and we're going to go right over here. That's my guy. Now picture this. We have 47 plus alerts for something called potential process injection via remote thread. And you're thinking, is this an attack? Or I mean, the problem is that the detection rule behind the alert looks like it was written by someone with a whole lot of sleep deprivation. Let's see that for just a second. I just want to show you this example here. It's this signal rule I'm talking about. Now, if I'm looking at the rule, at first glance, I can see some things that may be popping out to me, like that SVC host.exe, the run DLL32, the create remote thread. I mean, this stuff all sounds important, but what does it really mean? Is this catching malware? Is this a privilege escalation attempt? Or is it Windows being Windows? I need to know, bad or not bad. To that end, I can ask the AttackIQ Virtual Advisor, or AVA, about this and see what's really going on here. So what I'll do is I'll open up the AttackIQ platform, and you see I just open up AVA right over here. Now what I'll do is I'll go over and I'll ask Ava a question. Now I have asked this question, and I can always ask it again if I wish, but what I want to do is take a look at this, and this is the exact question that I would ask, is help me interpret this rule, and this is the exact rule that you were just looking at. So what it's doing is it's now going to send back a complete breakdown of what this rule is, what it's trying to do, how each and every bit of this detection works. So the SVC host.exe, it's explaining, the run DLL32exe, it's explaining, and the summary is that the Sigma rule is designed to detect potential process injection attacks where the process is created by SVC host.exe and uses the create remote thread function. The combination is suspicious because it can indicate an attempt to inject code into another process, commonly used by malware to execute malicious code stealthily. Now, it did all of this just on me asking that one question. So very easy for Ava to turn a cryptic rule into something written in plain English. And this isn't just some random Windows behavior. This is a classic process injection technique. It's often tied to stealthy malware or advanced persistence, and Ava can even tell us the MITRE technique IDs, because when I ask her that question right afterwards, she'll immediately come back and say not only the techniques and even the sub-techniques, if any of those are applicable, but it will also get into the M numbers, so any of the mitigations that should go along with these as well. So it's immediately starting to help me not only unravel the mystery of what this rule is, but also what should be done about it. I can take another example of this, and I did show this just a couple of seconds ago. This is a snort rule that I had. And the snort rule, again, if I'm not familiar with this, if I'm not a network expert and I'm used to looking at these rules, I wouldn't necessarily know to look over here, this HomeNet 445. I wouldn't know to look for this content and what it really means in the offset and the depth. But if I ask Ava that same question, I'm going to be able to get back the context of what it is that we'd be looking for here. So in this case, it's an Eternal Blue exploit alert. And that's what this is doing. Again, you see how we interpret this rule, and I paste in the exact rule. So Ava is telling me, okay, here's the destination IP and port that it's looking to go over to port 445. This is the content that it's trying to put within that packet payload. So it's giving me, again, a complete explanation of what this is. Now, unless I knew that exact exploit pattern, this would have looked like a whole lot of web searching and lost time. But with Ava, I've received a detailed breakdown of the rule and its components. In this regard, you can think of Ava as your translator for the ancient security scrolls, decoding them so you don't need an archaeology degree or have to call up a whole bunch of people that may no longer be there because they've moved on to other roles to understand the detections that you feel should be keeping you safe. So that's interpret. You don't have any more guesswork. Now we can move on to the next stage, the validation. Now that I know what this rule is supposed to detect, how do I confirm that it actually works? Now here, I'm going to get into the concept of where I'm trying to create an assessment based off of the rule that I have. Here, I would be trying to create an assessment. And this is where a lot of teams are going to give up, is in the validation of the detections. Now, why? Because setting up the right test is like recreating a dish with no recipe. But thankfully, we have Ava, and Ava brings us the cookbook. Now, I'm going to look at a detection-driven testing. And I'm actually going to use that same rule that we were just using here. So I'm going to take this, review this, and what it's going to do is, hang on, no, it's not this one. Yeah, so I want it to be right. So I'm asking Ava to do something very specific here. So what I wanted to do is summarize what the rule is detecting. I wanted to go over the logic and everything. But what I wanted to do is take this detection rule excerpt, and I wanted to give me a series of scenarios that are all based on that rule. So what it did was the agent took that rule, and it's now matching up all of the scenarios with everything that we already have in our library. This is stuff you can just pick right up off the shelf and use. So now that I've put that in there, instead of Google searching for days or spinning up random PowerShell scripts, Ava has handed me, and this usually comes back within about a minute or so, has handed me a shopping list of all of my ready to run scenarios. And I can take a look at any of these anytime, and Ava will explain to me exactly why it chose every single one of these scenarios. If I want to have Ava explain this to me further, I can click on another screen right here. And what it will have is Ava bring this explanation up for me. And I would just give her a couple of seconds, and then she'll send back all those results. I'm going to do more than one thing at once. I'm going to let her work. And at the same time, I'm going to ask, well, if the exact flavor of injection that I want isn't necessarily in the library, that's okay. I can ask Ava to help me build out a custom scenario in plain English. So what I'll do is there's another button you see right down here. This is Create New Scenario with the Ava Scenario Builder. I'm going to have her build me out something, script execution. Let's use Python. And now what I want it to do is, and let's just take this text that I can take right here. Now I can just take this and say, you know what, simulate a, oh wait, that's I want Python. And then go down here and say simulate this right here. So the svc host.exe, launching run DLL32 and injecting a remote thread using the create remote thread API. And I will send that in as that's going. I also want to go back and take a look at the other screen that we had open here. And look, here is my full explanation that Ava was giving me about this kind of threat. What's her analysis about it? What's the detection strategy for finding this? The rules that are aligned to this, the MITRE ATT&CK mapping for this, the testing approach. So this is everything that Roger's talking about with regard to being able to look all of this up and be able to find all this information very, very easily. I can continue asking more questions, like can I create additional Sigma rules? What are the MITRE mitigations related to process injection attacks like this? So Ava will continue to give me all of this information that I need. And now that I've gone and read through that, I go back and take a look for the script that I needed for this, and boom, here we go. So I now already have this script that I can now take. By the way, it's commented everything for me. It'll clean everything up afterwards if I tell it to. This is a completely interactive editor, so I can go and change all of these things as I want to. So it wrote all of this code live for me right in front of my eyes. So it was very easy for me to take advantage of this, and then I could just save this scenario, add it right to my assessment. And that's it. No scripting, no painful environment setup, just plain language to a working scenario. Now, without Ava, this could have taken me hours, maybe days. But with Ava, I have all of this context, the scenarios that I want, all of the background, and even more custom scenarios within a couple of minutes as I'm showing all of this to you while talking. And if I had gum, I'd be able to walk and chew gum at the same time. So I'm doing all of this stuff really quickly, really easily, and in parallel. The next stage that I would have here is I need to be able to measure things, right? And this is now when I would start to move over into the rules manager. The rules manager is going to go right back to what Raj mentioned earlier, the concept of how these detection rules age. They age terribly. I do not want to go back to that visual because no. But the landscape continues to change over time. That's just real talk, and that leans right into how these rules age. And here in 2025, that shiny rule from 2022 is either silent or it's throwing thousands of false positives. And what happens is nobody deletes anything because it ain't broke, right? But this is where a measurement becomes critical. Now look at this chart over here on the right. The red means that the rules have failed detection tests. That's what this is telling us. You see that upward slope all the way over here at the end? This is our technical debt in action. It's the rules piling up, failing quietly, making you feel secure because you got a whole lot of rules, but they're not actually securing you. Over here on the left-hand side, I have this bar chart telling me the detection rules by the integration. And here I can break it down by what happened in Sentinel, Splunk, Google Chronicle, or SecOps, and so on. Now, if the Splunk rules are failing at twice the rate of Sentinel, then I know where to focus my detection engineering efforts. This is also where it can get additionally powerful because I have this other tracker for everything that was tested, not tested, in progress. I can even allow you to pull in your SOC analyst feedback. So if they mark a rule as generating noise 10,000 times out of 22,000 alerts, we can reflect that also in, because when I take a look at this bar up here, in my precision and recall curves, another really powerful metric. So if I got a rule whose F-score is tanking over time, that's a candidate for either tuning or retirement. Now that's, I'll use your branding, Raj Addy, helping you tackle detection debt by objectively tracking what sparks joy in your SIM and allowing you to remove what doesn't. The measurement here isn't just about the dashboards. It's about reclaiming the sanity in a world where 90% of your SIM noise is noise. All right, so we've interpreted, we've validated, we measured. But what happens when the world throws us a curveball like a critical advisory dropping midday? That's where the generate phase shines. I'm going to take a look for a report. This one dropped from CISA. This is a real report. This is a real use case. It's 3 o'clock. CISA just published this advisory. This is not theoretical. Player ransomware has been hammering government and critical infrastructure networks worldwide. My CISO calls me up. We need detections in place for this before the close of business. Now, normally this could mean hours of reading this advisory, digging out the techniques, building Sigma, KQL, YAR rules, everything by hand. But today we have AVA. So now here's this advisory. It's 10, and I'm just scrolling right through it. It's 10 plus pages with techniques. I got PowerShell abuse. I got WMI queries. I got PS exec. I got credential dumping. I got a whole lot of fun in here. Turning all of this into actionable detections manually would chew up most of my day. What I need to do is, again, I want to ask Ava to help me with something like this. So what I would do is I would go back over into Ava again, and I would ask it to create some detections in Sigma and KQL for, and I'll just pop back up here, to something like this. So I just summarized this in a couple of sentences. So threat actors exploiting public-facing applications using valid accounts for initial access, performing discovery using WMI and PowerShell, then using PS exec and SMB for lateral movement. And here are some of the tools observed. Go. Create me some rules based upon this. So Ava is immediately going to go to work. It's going to help me with my analysis summary. It's going to get me a detection strategy. It's even going to build me out a rule based off of this. So after I've done that, it built me some behavioral detections, not just IOC lookups. All of this is here. It knows play ransomware lives off the land, so it focuses on PowerShell abuse. It focuses on WMI execution. It focuses on PS exec service patterns, exactly where the advisory says, or exactly what the advisory says the attackers are using. It even mapped them to MITRE techniques for me. So all of these are already here. Look at all of these tags. So once I start doing this, I can now start to justify the coverage to auditors because I have all of these behavioral patterns here. And by the way, it's also mapped back to MITRE attack very, very easily. So time to deploy is as simple as, okay, I already have the rule. So I click this, I deploy it, I'm done. The manual process for this, because now you see I already have all of my behaviors for this advisory covered in a matter of minutes. Whereas if I were to try to do this manually, it could be 4 or 5 plus hours. But with Ava, I copy the text, I hit enter, I may make sure I like to enjoy my afternoon coffee for a change. If only Ava could find my expense reports like that, I'd be really happy. But just future state, Raj, I'm just putting that out there. But the key message is I have some real world urgency here. I'm able to take this ransomware threat and be able to create a really fast response based upon it. My complexity is now simplified. It takes these advisories, all these multiple detection rules and multiple formats and puts it all together in a way that I could easily understand and also be able to easily test. I'm not just looking at my IOCs, but I'm looking at a way to catch the techniques that the attackers use. But I've not gotten to the best part yet because all of this stuff is great. And I could do it all individually and I could do it all day long. But we need to automate this stuff because I get that from my customers every single day. I need to automate this stuff more. And we're right there with you. Because all of this is done via the API, I don't want to click through the UI, no problem. From interpreting the rules to validating them with AttackIQ scenarios, measuring performance, generating new detections, I can do all of this programmatically. There is also an API that goes right along with this. So I can do things like send a Sigma, Yara, or Snort rule and get back JSON with plain English language explanation, MITRE mapping, prerequisites. I can validate things by getting Ava to suggest relevant scenarios to test. So you see all of these insights, the analysis, the recommendations. I can pull back measurements like my health scores, my precision and recall, put all of that into my SOC dashboards. I can build out Sigma, Yara, Snort, KQL, Suricata, lots more rules from any kind of descriptions, advisories, file samples, all of this. So whether you're building a detection as code pipeline, you're integrating this with your CI/CD, or you're just preferring automation over UI clicks, Ava's got you covered. This ADDI workflow that we're talking about is API first by design. That's why we built all of this, really all this groundwork here, so that we could build on top of it. And the UI is one great implementation of it, but we've also left that open to some interpretation. So with all of that, the full power, and I'll just shift back over to this screen over here. That's the full power of the agent-driven detection engineering cycle that we can interpret, validate, measure, generate, and we can do it at scale. Instead of spending days chasing YAML ghosts, fighting rule debt, Ava can help you understand any detection rule instantly, validate the coverage with real-world simulations, just like we've always done, measure the rule health continuously, and generate new detections in minutes, not in hours. You saw some of this stuff happen right in front of you. I was doing some of this stuff right here while we were on the call, as well as the other things that I've already shown you. So you can see all of the detail that Ava provides you. This was not just a demonstration, and we're not replacing detection engineering. Please don't get me wrong about that. We're not going to do your job for you, and we're not going to simply replace this function entirely. What we're doing is we're making it faster, smarter, fully automatable, and helping you realize a whole lot more value from that part of your infrastructure that you hold so dear, that you need to keep you safe, and that you invest a whole lot of resources in. So it's making your life a lot better. It's taking your detection lifecycle and moving it from reactive firefighting to proactive continuous improvement, whether it's through the UI or the APIs that are integrated into your pipelines. With that, Raj, I'll hand it back over to you for any conclusions, questions.
Well, thanks, Joe. That was really good. Now I will give it back to this. Liz, please take it away.
All right, so it looks like we don't have any questions right now. I know that was probably a lot of information for you guys. So if you do have any questions, feel free to email us at inform@attackiq.com. And we thank you all for joining us today. All right, you guys have a great day.
Thank you.
Thank you.